AP Calculus, this is question 6 that we're using for our review from AP Classroom. Consider this curve. This is an implicit function because the x's and y's are all together, the y is not by itself. Show that the first derivative of y with respect to x equals this. So we take this equation. Since it says the derivative with respect to x, we take the derivative of the left side with respect to x and also the right. Derivative of 2x squared is 4x. It's the correct variable, so nothing special happens. The derivative of 3y squared is 6y, so you take the 2 times the 3 and subtract 1, but it's the wrong variable. This is a y, this is with respect to x. So you do dy over dx, like the chain rule. Minus, this is a product because we have x's and y's in it. So the product rule, you take the derivative of the first term, I'm going to say 4x is the first term, its derivative is 4, times the second term, that would be y, minus, because I'm distributing this minus here, the first term, 4x, times the derivative of the second, derivative of y is dy over dx because it's the incorrect variable. Put your terms without dy over dx's on the right side of the equation. Factor dy over dx out of these two terms. That gives us this. Divide both sides by this. GCF a 2 out so they can cancel. And then we have proved what we were trying to prove. So we're 2 points, you get 1 point for taking the derivative correctly, and you get 1 point for showing this correct process. B, find the slope of the line tangent to the curve when x is 6. Well, when x is 6, if you put 6 into this equation, you're going to find out that there are two values of y, 2 and a 6. So there are two ordered pairs here. The reason we need to know what y is because our equation for slope, which we were given right here, has x's and y's in it. So using the ordered pair 6, 2, putting 2 in for x's and 6 in for y's, we get 4/3 as the slope. Putting in 6, 6, 6 for x and 6 for y, we get a slope of 0. So you get we get 1 point for each of those answers. Part C, find the positive value of x. That implies that there could be two values, a positive and a negative, at which the curve has a vertical tangent line. Show your work that leads to your answer. Vertical tangent lines happen when the derivative is undefined. The derivative is undefined when the denominator is equal to 0. So we take 3y minus 2x and set it equal to 0, which is what this is saying. You get 1 point for doing that. If you try to solve this for x, you're going to end up with an y value in this, so you won't know what the numerical value is. If you take the original equation that you were given, coupled with the 3y minus 2x equals 0, you have a system of equations. And you can solve that by elimination, by substitution, by graphing. Elimination and graphing are impractical. If we get y by itself here, we would add 2x to both sides and then divide by 3, and we would get this little fella. We then take this equation. Every place you see a y, you replace it with 2/3 x. We did that here and here. Square this, you get 4/9 x squared. Multiply these together, you're going to get 4 times 2, which is 8, over 3, and x times x is x squared. At this point, I didn't like the fact that I had these fractions, so I decided to multiply each term by 3. So 3 times 3 is 9, and that 9 cancels. Over here, 3 and the 3 cancel. 3 times 2 is 6. 36 times 3 is some number. You don't have a calculator, so if you don't want to figure that out, you don't have to. I did not. Once I get here, combine like terms. Once again, because those cancel, you get 4x squared, and the 3's cancel here, you get negative 8x. You get 2x squared. Divide both sides by 2. Square root both sides. Now, right now, you could simplify this if you want, but you don't have to. This appears to be the answer. Then I'm reminded, find the positive value, so I use the positive version. So I can use this for my answer. If you want to simplify it to this, you can. If you want to simplify it more, so you get 3 square roots of 6, I believe it is, you can do that as well. But on the AP final, you can just leave your answer like that. Part D, let x and y be functions of time t that are related to this equation. So it's a related rates. At time t equals 1, the value of x is 2, the value of y is -2, and the value of dy over dx is 4. That's why this is written here. I'll get to that in a moment. Find the value of dx over dt when t is 1. Once again, when t is 1, all these other things are true as well. To find the derivative of x with respect to t, we got to take this equation and take its derivative with respect to t. So here's the equation written. Take the derivative of the left and right side with respect to t, so I got to do it to each term. Derivative of 2x squared is 4x. It's the wrong variable. Put little sprinkles on it. Dx over dt. The derivative of 3y squared is 6y. It's the wrong variable, so we got dy over dt. And then this derivative here, it's a product. The derivative of 4x is 4. It's the wrong variable, so you got dx over dt times the y, minus the first factor, 4x, times the derivative of y, which is 1, but it's the wrong variable, so you got dy over dt. The subtraction here means that we have subtraction here and here. It's distributed. Once you get this, you get 1 point for that, by the way. You also get 1 point for taking the derivative with respect to t. If you plug in x is 2, t is 1, y is -2, and dy over dx is 4, you get this hot mess right here. And once I get here, I add 48 and 32 to both sides. If you don't want to figure out what that calculation is, you don't have to. It's the AP test. And then 8 and 8, they have the same variable, dx over dt is 16. And then divide both sides by 16. You can leave this as your answer. If you want to simplify it, it becomes 5 either way. So you get 1, 2, 3 points for this part of the problem.